Right, so I'm taking a look at the P1 paper for 2018. Now this paper was just sat, I think it was yesterday or the day before, so I don't have a mark scheme for this yet. That's important to note. This is my best attempt at the solutions, and I'm pretty confident in my abilities, but I haven't got a mark scheme to check they are the actual answers. So just take it with a pinch of salt, and if you've got any corrections for me, I would very much welcome those comments, and I can fix up the video if I've made mistakes. Question 1, 3 marks to find the coefficient of a term of binomial expansion. So that binomial expansion, if we do that, oops, to the 7th, you can go straight to the term, or if you don't think about it so easily, you can just think about those terms there. That'll be x to the 7th plus 7c1 x to the 6th, and then that second term there, which is the minus 2 over x to the 1, 7c2 x to the 5 minus 2 over x squared, and that carries on. You don't need to write out the whole thing. From that you should be able to figure out what you need to do to get a term that is 1 over x cubed. Now that will be the one that gives us the minus 2 over x to the 5th part that gets times by x squared, so that would end up with 1 over x cubed, and the bit that goes with that is 7c5. You can tell from the pattern. The next stage of that is to work out those numbers and then simplify it, so the coefficient that we're looking for is minus 672. Question 2 gives us a function to work out if it's increasing, decreasing, or neither. So first of all, I need to think about the gradient of this function. So if we differentiate fx, we get f dash x, which is our gradient function. My first thing is to try to express that in a term where I could say it's all positive or all negative, so therefore it would be increasing or decreasing. So we'll see if that works. So I'm going to do completing the square on it. It's a little bit of a tricky one to do. We need to take out the 3 coefficient of those x terms first, and then carry on from there. So once we've got the 3 out, we can do completing the square on this bit in the middle, and then tidy up the brackets. Okay, so it's not immediately obvious what's going on here. We do need to just pay attention to the fact we were told x is greater than or equal to minus 2, and that might have helped us out a bit, but actually it's not really. So if we just do a little sketch of that derivative function, that might help us to clear up and see what's going on this question. So it looks something like this. The central part of that will be at minus 2/3. The intercept will be at minus 8 over 3, and we've got this fact that x has to always be bigger than minus 2. So if you look at the derivative function, it can either be positive or negative above minus 2, so therefore it's neither. It's not increasing or decreasing, because at some points it's increasing, at some other points it's decreasing. The gradient is positive in places, negative in places after that minus 2, so it will be neither. Question 3 eases us into a question on circular measure. So first off, I'm going to just label this angle up here as theta so we can work with that, and we need to find the angle BAC. So we need to work out what theta is. We know that arc length equals r theta, and hopefully you're in the habit of writing down your formulas before you use them. So the arc length was 4 centimeters, radius is 5, theta we're working out, therefore theta equals 4/5. The next part is to find the area of the shaded region now that we know theta. There might be some more elegant ways of doing this than I'm about to attempt, but I'll show you how I worked it through. So first of all, just section off that bottom piece where you can see there's a rectangle. And I'm labeling that point where that rectangle corner is that we don't have labeled yet, x. So we can work out AX from the right angled triangle that we've got here. And similarly, we can do the same thing for CX. Now, since AB is a radius, that will also be 5. So then XB will be 5 minus AX, which was 5 cos 4/5. Now we can work out the area of the rectangle by multiplying those two sides together, the XC and the XB. And if you put that in your calculator, this is what it comes to. Now, once we've got the rectangle, we want to work out this bit here and take it away. So that will be the area of the sector minus the area of the triangle. So area of the sector minus area of the triangle, and that comes to 3.75266. So the shaded area will be this one here. So the rectangle minus that little segment that we worked out there. So BCDX, take away XCB, and that comes to 1.69 to 3 significant figures. For question 4, we've got these 2 points A and B. We're told about some other coordinate C, and the line B to C is perpendicular to AB, and it crosses the x-axis at C. So C is somewhere on the x-axis. B to C is perpendicular, so C looks something like this. Find the equation of BC. So if it's perpendicular, it will have a negative reciprocal gradient of then from AB. So work out the gradient of AB first by putting in the values of the coordinates. So we have 3/4. So therefore gradient of BC is equal to -4/3. We also have that B is on the line BC, and it has a coordinate of 3, 4. So we use y minus y1 equals mx minus x1 to find the equation of that line, and then we'll find out where it crosses the x-axis. So there's the equation, and when it crosses the x-axis, the y value will be equal to 0. So we can carry on with the calculation having a 0 in there and just do some rearranging. So you work that through and you get the final answer of x equals 6. So we just worked out the coordinates for C, that will be 0, 6. We've got A from the question, and we just need to find the distance between them using Pythagoras now. So subtract the x's, subtract the y's, square them, add it together, square root it. And to 3 decimal places, we get 5.099. Now note you've been asked to do it to 3 decimal places, not 3 significant figures like normal. So we've got an arithmetic progression and some information we're told about that I've just summarised underneath. So first of all, the nth term, we know we have that a plus n minus 1d gives us our nth term. So that will equal 94, and in fact the d we already know to be 3, so we can replace that. For the sum of the terms, I'm going to use the form of the formula where it's half n a plus l, since I think that will be a little easier to work with. We have got what the last term is, it's the nth term there of 94. So then we can set up 2 simultaneous equations. Then I'm going to use substitution, take equation 1 and substitute it into equation 2. And working through that quadratic equation there using the quadratic formula, you get n equals 40 or 23.67. Of course, n can't be a decimal, it must be a whole number because we're counting the number of terms, so therefore n must be 40. Question 6 is the vectors question. I won't read through it all, but it's basically exactly what it looks like. And we're being asked to work out the angle OBF. So this one here, we're going up to, oops, badly drawn line, but this angle here that we're trying to work out. Okay. Okay, so I'll just keep that up in the corner and give me some space to work. Now to use the scalar product, we need to have the two vectors coming away from the corner of that angle theta. So we need BO and BF, and it's very important you get them in the right order, not OB, but BO is what we want. Now BO, if we just read off all the directions it moves in the I direction it goes -8, in the J direction -6, and it doesn't lift up off the floor at all, so in the K direction it's a 0. Similarly for BF, we need to work through the vectors there. Now BF will be OF minus OB, and OF is 4, 2, 7. So then we can work that through and find that BF is -4, -4, -7. Next is to work through finding the angle. So we're going to use the scalar product, which it actually defined in the question that we had to use, and that looks like this. And if we put it in context of this question, it will look like this. So first thing is to work out the scalar product of BF and BO. And once we've got that, we need the modulus of BF and the modulus of BO. Then we've got all the pieces that we need to put it into the scalar product formula. So we've got 56 is the scalar product on the top, modulus times modulus on the bottom. So that gives us 56 over 90. Therefore, theta is the inverse cos of 56 over 90. And we didn't actually have to work it out. The question asked us to leave it in that form of inverse cos of a fraction. Question 7 is about trig identities. So the first thing that we're going to do is take that left-hand side and put it all over a common denominator. I'll just skip ahead a little bit. Now the bottom of that comes to 1 minus cos squared. And if you multiply out the brackets, you will get a very long expression, but we can start cancelling out some stuff. So we have a minus tan theta cos theta and a plus 1 there. We have a plus 1 and a minus 1 there. And of course 1 minus cos squared is sine squared theta. And then we will have what we were looking for from the beginning. Part 2 is a matter of using that identity to make this equation simpler. So substitute in that equivalent expression that we had from the other side. Actually, strictly speaking, we need to start with this over sine squared theta first, and then of course you'll take the numerator as being, this is the important part, tan theta minus cos theta would have to equal 0, and we'll carry on working through with that. Not sure quite why my pen just decided to change colour by itself, but never mind. And we'll go sine theta over cos theta. And I'll just skip ahead a bit for you to get this quadratic, which I'm just going to plug straight into the quadratic formula. And we get these two solutions for sine theta. Remember, it is sine theta that equals these, not theta. Don't stop short. And this solution here is not valid, so we will ignore that one and carry on with the other one. It's not valid because it's outside the range that sine theta can't go bigger than 1 or lower than -1. So sine theta must be 0.168. So therefore theta would be 38.17 degrees. So we've got an equation for the derivative of a curve, and we need to find the equation of the curve itself. So integrate that expression. From dy by dx, we need to integrate to get y, and we will get ax cubed over 3 bx squared over 2 minus 4x, and then don't forget, add a constant at the end. We're going to use the fact that it goes through 0, 11 to work out that constant, evaluate how much it will be worth. So therefore C is 11. So we know there's a stationary point when x is 2, and we can put that into the equation we had on the first part for the function of the derivative. Right, there's one of the equations that we'll need to do simultaneous equations, and then we need another one. So we know that when x equals 2, y equals 3, because that's also a point on the curve that we're told about up here. It's the stationary point. And we got the equation of the curve from part 1, so we'll just plug those values in. So now we've got two equations to solve simultaneously. We'll call this one equation 1 and this one equation 2. And you can do it by elimination or substitution or whatever. I'm just going to do equation 1, take away equation 2, or the other way around. It doesn't really matter, just to get rid of the 2b. So question 9 is talking about points of intersection. We've got these two equations of a line and a curve, and we're looking for the situations of their intersection. So part I is showing us that they will always meet. So we are looking for the fact that the discriminant will always be positive here. If we set those two equations equal to each other and then try to figure out the nature of the roots of that equation. So rearranging, we get this, which we can then go on and pull out the discriminant from that quadratic as being the following. And that comes out to 9k squared plus 6k plus 1. We want a way to be able to show what the nature of this is going to be in a definitive situation. So we can actually do that by rewriting this using completing the square or factorizing, whatever works for you. But this comes to 3k plus 1 squared. And then just finish it off with an explanatory sentence to get that last mark. Since the expression is squared, the discriminant will always be positive. There will always be a point of intersection. There will always be a solution to that equation. Part 2 is talking about when that line will be a tangent. For the tangent to happen, we need the discriminant to be equal to 0. And we just worked out the expression for the discriminant was 3k plus 1 squared. So we have to set that equal to 0. So k is equal to minus a third. And now we need the coordinates where that line touches the curve. So we are solving to find that point of intersection. So there's the two equations when k is equal to negative a third, set them equal to each other, rearrange into a quadratic, and then solve for x. So x will be minus b, which is 8 over 3, plus or minus the discriminant, remember, so the square root of the discriminant, which we know is going to be 0, so I'm not even going to bother with the working out there, because it's tangent, that discriminant will be 0, all over 4. Therefore x equals 2/3. When x is 2/3, substitute into the equation and we get y is minus 1/9. Question 10 is a volumes of revolution question. So I'm just going to shrink that into the corner. So for the volume of revolution, we need to integrate pi y squared dx between the limits of 2/3 and 3, and y squared will be 4 3x minus 1 to the minus 2 over 3. Integrating that requires the reverse chain rule or a little bit of trial and error if that's your thing. So that becomes, or I should have put another line here. So this was pi times the integral of 2/3 and 3, and then substitute in what y squared is. Okay, so if we integrate that, we get 4, 3x to the minus 1 to the 1/3. So evaluating the limits, substituting them in, and we get the very nice solution at the end that it's equal to 4 pi. Next, we want to find the equation of the normal. So first of all, we need the gradient at the point that we're talking about, which is at A. And A happens when x is 2/3. So we need dy by dx. Using the chain rule, we get this. So when x is 2/3, dy by dx will be equal to -2 if you substitute that in, and y is also 2 at that point. That'll be enough information to be able to work out the gradient of the normal, which of course will be the negative reciprocal, so that's half, and then the equation of the line, and we've got the x and y coordinates as well. Question 11 starts us off with a fairly straightforward completing the square. Part 2 leads on from part 1, and we want to know when it's 1-to-1, and that will be about something to do with the shape of it, which is like this. Okay, so we need to use part 1 and express that in the form that we just worked out, so we can see what's going on a little bit more easily. So if we think about what that looks like, this curve here will bottom out at its stationary point when x is 3. So therefore, if we're looking for this portion here where x has to be less than some number, so this x minus k malarkey up here, then x has got to be, we need to be able to cut that graph in half there. So the x has got to be less than or equal to 3. So k largest value is 3. So for this value of k, find an inverse. So it's, if we know that that value of k is satisfied, we don't need to worry about it being 1-to-1. So now we need to just find the inverse. So write this out and swap around the x's and the y's and do some rearranging jiggery-pokery. Once you've done the rearranging, then we're just going to rewrite that. So the inverse function of f of x will be 3 plus the square root of x plus 7 over 2. And we also need to state what the domain of that is. Easiest way to think about it is what the range of f could have been. So over here, this expression can be anything that's greater than or equal to -7, because this part here will always be positive, and then you take 7 off of it. So the smallest it can be is -7. So therefore the domain of the inverse will be exactly the same. So on this inverse function, x can be greater than or equal to -7. You can think about it in terms of this expression that we have here as well. Of course, it wouldn't make sense for x to be anything less than 7 because you'd end up trying to square root a negative number. And finally, we have this second function g of x, which is simply defined as x plus 3. We're told that now k is taking the value of 1 for the function f of x. So x will be greater than or equal to 1. Oh, sorry, not greater than, less than. So less than or equal to 1. Okay, now working through this question here, we want to find the largest value of the constant p, which allows us to create this composite function fg. Okay, so let's just think about what fg would look like first. So fg of x means we're going to take g of x and put it into f of x. So tidying that up, it looks like this. Okay, now that's the expression for fg of x, and we need to be very clear on what we understand for the value of p. So p is part of the domain of g, so those are all the things that can go into g. Now g is determined by what values it's allowed to take on to then be plugged into f. Now f, we're told that for f the x values have to be less than or equal to 1, which means all of our answers from g must be less than or equal to 1. So g of x is not allowed to get more than 1. So then if we substitute x plus 3 in for g of x plus 3 must be less than or equal to 1, therefore x must be less than or equal to minus 2. So there's the restriction that we need. So the largest value of the constant p, so the largest that p can be is minus 2. P must be less than or equal to minus 2. The reason being that if it got any bigger than minus 2, it wouldn't satisfy the conditions required for f of x at the moment. Once you plugged it into g, that g function would get too big and it wouldn't be allowed to then go into f.